food.
That is delicious.
The supermarkets are full of it, from the everyday to the exotic.
Welcome to Africa.
But how much do we really know about the grub we eat?
That is officially runny honey.
We'll be travelling the world,
Oh, a little bit bumpy.
tasting everything we can, and taking on any challenge
That's mental.
to reveal the secrets behind the food on our plates.
Proper mouthful.
Coming up, I discover how packaging is polluting the food chain.
As the mussel starts to feed, it's drawing in these plastics.
I try to lift the lid on the secrets of Marmite.
Will you let me unscrew?
No, that's how secretive we are.
Oh, my God.
And thanks to the utterly bizarre physics of packet custard,
Okay.
I discovered the solution to the age-old problem of getting ketchup out of a bottle.
That has totally changed my life. I love that. Cheers.
First up, yeast extract.
Cheers, buddy.
We sent Matt out onto the streets of Brighton.
What do you think it's made of?
I have no idea.
It's like a really reduced beef stock.
Do they just culture the yeast and then scrape the top off? I don't know.
It is bacteria.
Malt and salt. Do you like it?
It's good. I like it.
No?
Nope.
You don't like it, you do.
Love it.
You got kids?
Yeah, 4. 4.
Blimey.
Oh, love it.
Do you think you might grow to like it?
I can't see myself ever enjoying this, ever.
Not everyone's a fan, but I want to know what yeast extract is and why it tastes the way it does. I've come to Burton-upon-Trent in Staffordshire, where I'm hoping to uncover the secrets of this particular brand of black magic.
Hello.
Yeah, I'm St John.
Lovely to meet you.
Wow, it's an honour to meet you as well, and an honour to show you around Britain's finest factory. Come and have a look
Britain's
at
finest.
this. Easily.
You do know St John. I've been around a few factories.
Oh, of course.
My new mate, St John Skelton, is the quality specialist at this factory of epic proportions, where they've been spreading the love since 1902.
Look at this. What is delivered in those?
Each one of those will hold 26 tonnes of yeast.
Where do you get the yeast from?
Now, that yeast comes from breweries. When breweries make beer, they take a sugary solution and they'll add yeast to it, and the yeast will convert the sugar into alcohol.
The yeast cells multiply as they produce alcohol, and as a result, the breweries end up with 7 times more yeast than they started with, which is sold to make yeast extract.
That explains the smell. Like right now, it
Smells
smells like beer.
Smells of beer.
When it arrives from the breweries, it's pumped into large vats called coppers.
What's happening there is we adjust the temperature so the yeast starts to decay.
The coppers are heated to 95 degrees, which kills the live yeast and breaks down their cell walls. The yeasty soup is then put through a centrifuge to separate it into 2 liquids, the broken down cell walls and the cell innards.
You've gutted every single cell of
Everyone.
that yeast, and that's what's in here, and that is yeast extract.
That's it.
But St John, I'm not going to spread that on my toast, am I?
No. Come and have a look at another piece of equipment, which is wonderful.
I'm coming.
Now, just look at that devil, isn't that magnificent?
Is it a chimney?
Oh, no, not at all. That will heat up the liquid and boil off steam.
So can we see what comes out of it?
Of course we can. There we
I'm
go.
working towards that hot buttered toast.
There's
When am
no
I going to get it?
So once the water's evaporated, the yeast extract becomes concentrated and should start to look like something a bit more familiar.
Now, here, we've got a sample here for you to look at.
Oh, look, now
There
we're
we are.
talking. Slightly tastes like there's a little something missing.
And so we add secret ingredients, and I'll show you where we add them.
I love a secret ingredient. We're on a mission. I've got all senses on the go. I'm sniffing the air.
Here we are. This is the secret ingredients. Look at this. Look at that.
Is it?
Okay.
Can I have a sniff? Can I open it up?
No. There we go.
No.
No, that's it.
Really, St.
Yes.
John? I don't know if he's joking or not.
He's not joking.
He's not joking.
He's not joking.
Well, your secret's safe for now, St John.
It is very red, isn't it?
According to the label, it contains barley, salt, vegetable juice concentrate and celery. But whatever it is, it's blended with the yeast extract and fills 25 million jars a year.
Here's Steve.
Hello, Steve. Kate.
Okay.
Steve Jones is lead operator in production.
Do you have to eat it at work ever?
Yes. To make me taste test it. You adore it, don't you? Ah. No. Horrible stuff.
What? I want to try this. I haven't tried it yet. I want to try the finished product. I don't know what that secret ingredient is, but it makes a difference, doesn't it?
To find out where some of it ends up, I'm heading to Granton Harbour, just outside Edinburgh, to meet Catherine Gemmell from the Marine Conservation Society.
Hi there, I'm Jim.
Hi, how are you doing?
Nice to meet you.
Catherine, lovely to meet you.
No, I'm here to find out about plastic.
Oh, well, unfortunately, you've definitely come to the right place. Do you fancy getting stuck in?
Yeah, let's do it. So doing a bit of a beach clean, are we?
We are. So unfortunately, we're finding some horrific things down here.
What is all this? What does this represent?
So unfortunately, this is everything that we found on the beach just in the last 2 hours.
Look, who throws a tent away?
It's just madness. By 2050, potentially there could be more plastic by weight in the sea than fish.
No way. More plastic in the sea than fish.
It's estimated that globally 8 million tonnes of plastic is dumped in the ocean every year. And it's having a devastating impact, as this footage from Greenpeace shows.
These big bits of litter are just the tip of the iceberg. So unfortunately, once litter enters the ocean, it'll continue to break down into smaller and smaller pieces until they become what we call microplastics.
Microplastics?
Yes.
I've come to Exeter University to meet marine biologist Dr. Matthew Cole, who's an expert in microplastics.
Hi there, I'm Jim.
Hi, I'm Matt. Nice to meet you.
Nice to meet you.
Come with me and I'll show you our lab.
Right, so what are you looking at here then?
This is what you might find on a typical beach.
These are just like bits of plastic that are broken off from larger pieces.
What we tend to find is that over time, these plastics begin to get brittle by the sunlight, and through abrasion, they begin to break down into smaller and smaller pieces until they become microscopic in size.
Wow, you can see, so still sort of grainy there, but all the way down to here, which is super fine.
Yeah, they're called microplastics, and it's a growing threat in the marine environment.
To show me just how big a threat these microplastics are, Matthew's enlisted the help of a familiar-looking mollusk.
This is the same species that you would buy if you're going to have mussels for dinner.
Yes, absolutely. So what we're going to do is we're going to add some...
Bit of white wine, some garlic, some shallots.
Well, today we're just going to add some seawater.
Ignoring my culinary suggestion, Matthew's recreating an ocean environment for our hungry mussel.
We can see that he's opened up and started to filter feed. What I'm going to do is just going to add some PVC particles in seawater.
PVC stands for polyvinyl chloride, a common type of plastic.
Wow, yeah, it's just like tiny little specks of dust, that's all.
As the mussel starts to feed, it's drawing in these plastics.
Oh, there you go. They're going straight in. They're getting sucked in. It's like the tractor beam on the Death Star.
That's right. They can't tell the difference between the plastic and the food, so it all goes in.
So what's happening there is happening across our oceans with these little filter feeders.
Well, this is something that we've been investigating. So I've got some mussels that I've collected from local estuaries that I can show you to see if they contain any plastic.
Let's have a look, yeah.
Matthew's dissected the flesh of a different mussel to see what shows up under the microscope.
So I'm just going to pop this onto here. I've just spotted something that's bright blue for you to have a look at down there.
Oh, yeah, look at that.
You can almost certainly say that's a piece of plastic, or microplastic.
So the seafood we're eating, when it comes to shellfish in particular, there will be a chance that I'm absorbing the plastic.
Unfortunately so.
Not enough scientific research has been done to determine the impact this is having on us humans. But regular seafood eaters could be consuming up to 11,000 pieces of microplastic a year. Later, I discover a possible solution to the plastic problem.
Oh, really? That is bad.
From a very unusual source.
I'm heading to Greenwich University, and I've been told to dress down for the occasion.
Dr. Tim?
I'm here to meet mathematician Dr. Tim Rees, who for some reason has studied the unique qualities of custard.
Tim, what are we doing?
Well, I'm going to ask you to run on this pool of custard.
But it's a liquid, right?
It's a liquid.
I mean, my science is pretty basic.
It looks like a liquid, but in fact, it can act like a solid.
Ready?
Go for it.
Sorry, that wasn't supposed to happen. OK. Oh, my God, that's... I have to keep going?
You have to keep going. If you stop, you will sink.
Right, so what's going on?
As you're hitting this fluid hard, you're pushing those cornstarch custard powder particles together. They lock, and the friction makes them act very strongly like a solid. It's a non-Newtonian fluid, which means it's a fluid that doesn't behave according to Newton's law of viscosity.
This turns the physics of Sir Isaac Newton on its head. So, here's the science bit. 1 part water is mixed with 2 parts custard powder to create a non-Newtonian fluid. When a force is applied to the liquid, at the point of impact, the water molecules are squeezed out from between the rough cornflour molecules, causing them to temporarily lock together to form a solid.
Everyone got that? Can I stop now?
And the moment you stop, you will sink because it goes back to being a fluid.
It's a liquid, but yeah, you can do this.
Yeah, it's almost like a liquid and a solid, depending on how you play with it.
That is so much fun. And is this the only food that does this, or are there others?
It's certainly not the only foodstuff that exhibits some kind of non-Newtonian behaviour. Tomato ketchup, for example.
Ketchup?
Yes. You must be tired after all that running.
Yeah.
Time for a break.
Yeah.
Bit of lunch, I think.
Yeah.
Come on, Matt.
Hey! Is that quicksand?
Who'd have thought custard would have led me to ketchup?
Now, I like ketchup, like the next man, but getting out of the bottle, nightmare.
Maybe the great British public has a better idea.
Shake it up a bit, yeah, and smash the end. No, don't do it. Just mime it. Don't actually do it. She's just really.
I should really go for it because the problem is with these, you can't get it out.
I'm here to catch up with Professor Alan Mackey, an expert in rheology. That's the study of how things flow. Perhaps he's got a few saucy ideas.
So, Alan, listen, I always have a problem with ketchup ever since I was a kid. Either do that and it goes everywhere, all over the table, or it takes ages.
What's happening in the bottle is that there's a polymer in there, a thickener, and when the bottle's just sitting stationary, the polymers entangle. So when you turn it upside down, it doesn't flow. Obviously, when you hit it on the bottom, you tend to make the entire jar liquid if you hit it hard, which is not what you want.
And that's why it comes out.
And that's why it comes out in a big splurge.
In ketchup, soft particles of tomato are suspended in water, which is thin and runny. But the ketchup also contains long chains called polymers. And when these chains get tangled, it makes the sauce thicker. Bang in the bottle causes the polymers to disentangle, and the sauce gets runny. So it works the opposite way round to custard. The liquid gets thinner, not thicker.
What I would do is tap the neck, and that liquefies the neck region and has a controlled flow over your chips.
Right, come on in.
I want to put our ketchup techniques to the test.
The idea is we're going to fill these little plastic pots with ketchup. You're going to use your method, and I'm going to use mine, and we'll see who can fill the pots most quickly and accurately.
OK, proper science, this.
Proper science.
Right, you ready?
OK.
3, 2, 1, go.
I'm banging the bottom of the bottle, and the whole bottle suddenly liquefies.
Use the bottle.
But Alan's just banging the neck of the bottle, and it's only there that the liquid becomes thinner. It's clear who has more ketchup control.
Right old dog's dinner, isn't it?
It is. When you bang the end of the bottle, you don't have much control over how much liquid you're producing.
So I think I've got it. A non-Newtonian fluid means a liquid doesn't behave like water. If you apply a sudden force, some liquids solidify, like custard, or liquefy, like ketchup.
So I've been doing it the wrong way for about 40 years. It's totally changed my life. I love that. Cheers.
Unusually, that's something the makers have taken full advantage of. Since the 90s, Marmite have been running a very clever advertising campaign. This commercial from 1996 shows extreme examples of people hating it.
As a company, to go out there in the world and say, we know that people love our product, but we also know that people hate it. I mean, that is pretty bold, isn't it? But recently, they've taken this campaign to a whole new level.
The debate continues into the 21st century in their new ad, where families are now using DNA tests to see if they love or hate it.
What does it say? You're a hater.
Like this mum-to-be who's just found out the father is a hater.
I'm carrying a hater's baby! So is this real science, or is it just a really clever marketing campaign?
Marmite are working with a DNA sequencing company to explore the love-hate divide. So I've come to meet Andrew Steele.
Andrew!
Good to meet you.
Kate!
How are you?
I'm very good. Yeah. I'll be honest with you, I mean, this sounds like a brilliant and very expensive project that... I mean, is it just marketing or is there actually some real science going on?
Well, this is very much real science, and actually we have two different independent scientific groups looking at the results to make sure this is true.
So what is it that actually determines our tastes in life?
Well, what it appears, especially in this case, is actually both genetics and environment. Where we grew up, like our family's preferences, the environment in which we live, that plays a role as well.
Are you proposing it's one gene? Because I'm thinking, you know, 100 years, which is how long yeast extract's been around, that's not quite long enough for genetic evolution, is it?
No. It doesn't appear so. There's actually a selection of about 14 genes that we found that have a genetic basis here on this. So there's no one gene, so actually a selection of genes contribute to this, like, preference.
So if you took a swab from me, would you be able to tell me whether I'm a lover or a hater?
Not in such black and white terms. What we've found so far gives us enough to say you're a likely lover or hater based on 14 gene results.
I used to hate yeast extract as a kid, but now I love it. So how does that fit with genetics?
Right, Andrew, what have I got to do?
You're going to just rub that inside your cheek just to collect some good saliva cells on there so we can analyse the DNA. Up and down, maybe under the lip.
Critics in the press say this test doesn't prove conclusively that there's a set of genes that determine our breakfast spread preferences, as the results are too open to interpretation. But Marmite have invested £3 million in this campaign, so they must be convinced.
And that's probably OK, yeah.
I reckon the crew should get swabbing too.
So, Becky, crack that open. There's your little DNA test. Should we swap? I'm going to shoot you doing yours. That's it. Open wide, Ollie.
It's going to take Andrew 10 days to analyse our DNA before he can tell us if he thinks we're genetically destined to like or dislike Marmite.
OK, brilliant. So we'll catch up with you in 10 days.
Sounds good.
I am intrigued.
And just a week and a half later, the DNA results for me and the crew are in.
So first up, our cameraman. Give your little camera a nod. Tell us, are you a lover? OK, you love it. Ollie, according to the DNA guys, is a lover. Wow. Right. Becky, are you a lover or a loather?
I'm a loather. I hate the stuff.
Let's see. Becky. According to your DNA, you are a lover. How? I definitely don't like it, so I don't know how I could be a lover. Let's have a look for me. OK. I'm a lover. Spot on. Well, you know, that was a hit rate of 2 out of 3, but I'm still not convinced. I'm not sure I need a DNA test to tell me whether or not I like this stuff.
Now I've come to Quantech in Lanarkshire, Scotland, to meet Dr. Kate Murray-Green.
Hi there, I'm Jim.
Hello. Nice to meet you.
Nice to meet you.
Kate is working on a possible plastic alternative.
Right, lab coat on.
Yes, please. So here we have some langoustine.
So some quite smelly langoustines, I must say.
Absolutely. These are the bits that don't get used for scampi. These are the bits that get thrown away.
So what are you doing with the shells, then?
Well, what we do is we crush them up to start with. Do you want to give us a hand?
Right, OK. There's a lot of crunching and snapping.
Yeah.
Ugh.
You end up with...
This is stinky and slimy. So why on earth are we mincing up stinky langoustine shells?
Because there is a substance within that mixture which we can turn into plastic.
This minced-up mixture is left to ferment.
Oh, really? That is bad.
This pongy process extracts chitosan, a natural polymer, which is what langoustine shells are made of. The chitosan is then mixed with starch.
It looks like wallpaper paste, doesn't it?
And the paste is spread out, dried, and voila! An eco-friendly plastic that's biodegradable and made from food waste.
Wow, that is incredible. So we've gone from a load of smelly shells to some plastic film.
And it does something else. It's antimicrobial, which means it can help your food last longer. Here we have a piece of salmon wrapped in our material. That was bought 6 days ago.
It doesn't have any off-fish smell at all.
Chitosan is naturally antimicrobial. It kills off bacteria and mould around it.
Are there any other competitors out there?
Absolutely. There are other people who are working in the area all the way across Europe and using different materials, not just chitosan.
Kate's team are looking to release their product in the next year. It might not clean the oceans, but this new material is an example of the pioneering work being done to keep plastics out of the environment and our food. So when it comes to plastics, there's definitely a sea change.
Absolutely, and hopefully a change in the sea as we manage to make the environment healthier for all.